Good day to all of you. We have started studying database management systems. In that today we shall study chapter 5, that is the relational data model and relational database constraints. Our sincere thanks and acknowledgement to the authors Ramesh Elmasri and Shamkat B. Nawate, authors of the textbook with title Fundamentals of Database Systems. Relational model concepts. The relational data model means the data is stored in the form of relations or tables. It was first introduced by Edgar Frank Ted Codd of IBM Research in 1970. The relational model represents database as collection of relations. Relation means table in which the data is stored in the form of rows and columns. Each row has values corresponding to real world entity. Means any object that we find in real world, that is called as entity. For example, student. So student related data will be stored in one relation or table called student. So in that one row has all the details regarding one student entity. Like that, many rows means many student entity details will be stored. Row of data is called as record or tuple. The column names are properties of entity and they are called attributes. Means in that table, the details of student, what details we store, that is student USN, student name, student marks. So whatever properties of entity we are storing, they are attributes. So they become the columns in the table. The set of attributes which represents the structure of relation is called as intension. The values stored in all the rows for all the attributes in each row are together, they are called as extension. The number of rows present in a relation is called its cardinality, and the number of columns present in a relation is called as degree of that relation. The range of values of specified data type allowed for an attribute is called as domain for that attribute. Okay. All these are shown in the next figure. Let us consider an example relation or table, that is the name of the relation being student. It has 7 columns and 5 rows. So 7 columns, the number of columns becomes the degree of the relation. The number of rows becomes the cardinality of the relation. So the column names are the properties of student entity which are called as attributes. The attributes are name, SSN, home phone, address, office phone, age, GPA. Here one row of data is called as one record because it is the details of one student entity. Similarly, 5 student entity details are stored. This is first, second, third, fourth, fifth. So 5 records are present in this relation. These are the values for age attributes for different entities. So if the range specified is 15 to 50, then the values here stored for any tuple for this age attribute cannot exceed 50 and cannot be below 15. That is the range of values specified for an attribute that becomes the domain for that attribute. So these are some of the terms that we come across in the topic relation. Okay. Next we'll see what is relation schema. Relation means table, schema means structure. Here relation R, its structure is denoted by R in bracket A1, A2, dot till AN. So R indicates the name of relation. This set of A1, A2 till N indicates they are the order list of attributes. So example, the name of relation is student. In this order list of attributes, it has name attribute, SSN, home phone, address, office phone, age, GPA. That is what is shown in the relation here. So this is whole relation shown here, and here relation schema, its structure is shown. So this is relation schema and this is relation. Okay. Consider employee relation. In this, a tuple is taken for example, that is T. This belongs to James E. Borg. So that is this tuple. So James E. Borg, the three attributes F name, M init, L name, that is James E. Borg, are given here in the tuple T. So the next one is SSN attribute value, that is 888, 66, 5555, that is given here. B date value, that is birth date value, that is taken here. Address value, this is here. Then gender value M is taken here. Salary value 55,000, that is included here. Super SSN, that is null, is given here. DNO, that is department number value 1, is taken here. So all these values which are given in the tuple are listed here in the same order as attributes. Okay. So tuple T in a relation is ordered list of all the values which will be listed in the same order as that of attributes. That is first point. This is whole tuple. If part of the tuple is required, so in tuple T only L name attribute value. So we write this way, T in square brackets L name. So that is equal to Borg here, because in this tuple T, L name, if you take that attribute, its value is Borg. So this refers to part of the tuple. Similarly, another example is in this tuple T, so SSN attribute, salary attribute and DNO attribute, their values means here SSN value, salary value, DNO value, they are given here. So this way we can refer either to the whole tuple in a relation or part of the tuple in that relation. Okay. Next we shall see two characteristics of relations. In that first one, with respect to ordering of tuples in a relation. A relation is defined as a set of tuples. The tuples in a relation do not have any particular order. That means if you consider student relation here, there are 5 tuples. So first, second, third, fourth, fifth. 5 rows means 5 tuples. 5 student entity related details are stored in each one student details. Okay. So the first one, it is having a set of values for each attribute. So name value, this is given here for SSN, then home phone, address, office phone, age, GPA. For all the attributes in each tuple, values will be given. So this is the first tuple, this is the fifth tuple. Now if you shift it to first place and shift the first tuple to last place, it doesn't matter, because all the values which represent a student entity, they represent that student entity only. So this belongs to Benjamin Bayer. If it is shifted here, all the values will be shifted. Then that will be representing that student entity only. So that is what is, if you change the order of these tuples from one place to another, they will be representing corresponding student entity only. And that is what is this ordering of tuples in a relation characteristic. A relation is defined as set of tuples, and tuples in a relation do not have any particular order. In any order they can be stored. Okay. Next, a second characteristic of relation, that is with respect to ordering of values within a tuple and an alternative definition of relation. A tuple is an ordered list of values. N tuple is an ordered list of n values. So ordering of values in a tuple is very important. That means if you consider this tuple here, that is third tuple, the name attribute has value Dick Davidson. SSN attribute has value, this is filled here. For home phone attribute, null is filled. For address attribute, this address value is filled. For office phone, this number is filled. For age attribute, 25 is filled, that is the value. For GPA attribute, the value 3.53 is filled. Okay. So this tuple can be represented as, here all the values are written as a collection here. This is ordered list of values for the attributes, because these values are written in the same order as the attributes which are present in the student relation or in the student schema. We cannot interchange. This cannot be written here because that place represents name attribute. So that name attribute value only must be written here. Okay. That is why according to the order list of values, this tuple T can be written as this. This is one representation. All the attribute values will be written in an order same as that of attributes or column names present in the relation or in the relation schema. That is one representation where order is important. The second representation of the same tuple T is this way. So in the first one, name attribute and its value both are written together in first place here. The same thing is written in second place in the second tuple. Similarly, SSN attribute and its value is written in second place in the first tuple here, and it is written in the third place in the second tuple. That way, if you compare all the attributes and their values in these two tuples, they are same. Hence, both represent the same tuple T. So, the order of attribute and its value, that is not important. They are the self-describing data. So, representation of tuple in the form of attribute name and its value, that is called as correspondence between attributes and values. In this kind of representation, the order is not important. Okay. That is what is the second characteristics of relation, that is ordering of values within a tuple. And an alternative definition of relation means relation is a set of tuples where order is not important, but in each tuple there is order among the attributes. But if we take attribute name and its value pair for representation, in any order they can be used to represent the tuple of the relation. Okay, that is all about second characteristic. Next, the third characteristic of relations, that is with respect to values and nulls in the tuples. So in tuples we store the values for attributes. There we can store null in case if the attribute doesn't apply to that tuple, that is the first case. Even if it applies, whether that value exists or no, we don't know. In that case, null value is filled. Even if it exists but that value may not be available at present, in that third case, we fill null value. If you consider third tuple in student relation here, name attribute is filled with Dick Davidson. Then SSN attribute value is stored. Address attribute value is here. Office phone attribute is here. Age attribute value is 25. GPA attribute value is given here. But home phone address value is filled with null. That means this student may not have phone at all. So whether it exists yes or no, we don't know. Then null value can be filled or it is filled. Then even if it exists at present, that value is not known. That is second case. And in certain cases, this attribute only will not be applicable. That is in case of citizen relation, for degree attribute, if that citizen is uneducated, then null value is filled because that doesn't apply to that attribute. That is the third case. And that is what is the three cases in which null value is filled for an attribute. So when you compare two tuples over an attribute, if null values are stored for that attribute in both the tuples, then while we compare it leads to ambiguity. That is why during database design it is best to avoid null values as much as possible. And that is what is all about the third characteristics of relations, that is with respect to values and nulls. Okay. The fourth characteristic and the last characteristics of relations, that is with respect to interpretation of a relation or meaning of a relation. So whatever from real world we get objects, that is entities, they are converted to relations finally. Similarly, relationships also do become relations in relational data model. Okay. If you consider this entity relationship diagram of company database, we have employee entity, project entity. Works on is the relationship between the two. So employee entity becomes a relation in relational data model, and project entity also becomes a relation in relational data model. Similarly, this works on relationship also becomes a relation in relational data model. That was ER diagram of company database. This is relational schema diagram of company database. It shows here employee relation, department locations relation, project relation, dependent relation, and this is works on relation, which is resulted from relationship. So entities are converted to relations in relational data model. Similarly, relationships are also converted to relations. And this is what is the final company database, that is collection of relations, that is employee relation, department locations relation, project relation, dependent relation, and works on relation, which has resulted from relationships. Okay, that completes the discussion on characteristics of relations. Next we shall see two relational model constraints and relational database schemas. The state of whole database will correspond to the state of all its relations at a particular point in time. State means values. State of relation means what values are stored in a relation at a particular point in time. State of database means what all relations are present in a database. So the set of values stored in all the relations becomes the database state. There are many restrictions or constraints on the actual values in a database state. Means whenever a user stores some data in a database or relation, that user has to follow certain rules. They are called as restrictions or constraints. Relational model constraints are broadly classified into two types. The first one is state constraints, second one is transition constraints. In state constraints, again there are three types of constraints. They are, first one, inherent model based constraints or implicit constraints. Second one, schema based constraints or explicit constraints. Third one, application based or semantic constraints or business rules. So these three belong to state constraints. So here in the second one, in state constraint, that is schema based constraints or explicit constraints, again there are five types of constraints. They are, first one, domain constraints, second one, key constraints, third one, constraints on nulls, fourth one, entity integrity constraints, and fifth one, referential integrity constraints. Apart from these, we have another important category of constraints, that is data dependencies, which includes functional dependencies and multi-value dependencies. These two come under the topic normalization of relations. Next we shall see all these constraints one by one. Okay. First, inherent model based constraints or implicit constraints. The constraint that a relation cannot have duplicate tuples is an inherent constraint. That means in a relation, two rows of data, that is two tuples, cannot be similar. That is what is the meaning of this constraint. Next we shall see to second type of constraints, that is schema based constraints or explicit constraints. This is the second type in state constraints. So in this schema based constraints or explicit constraints, there are 5 types as already mentioned. So the first one is domain constraints. Domain constraints specify that within each tuple, the value of each attribute A must be atomic value and it must be from the domain that is of attribute only. The domain of attribute refers here data type and range of that attribute. The meaning of this is, for example, if you consider employee relation in that tuple 1, so and salary attribute. So the domain of salary attribute, if data type is int and the range mentioned is 15,000 to 95,000, then for any tuple, what user enters the salary value, that is 30,000, must be of integer type only and must belong to this range. It should be within this range. So that is what is the meaning of domain constraint. The value that user enters for any attribute in any tuple in a relation must belong to domain of that attribute. Means it should be same data type as mentioned for that attribute and the value should be within the range specified for that attribute. Okay, that is what is the meaning of domain constraint. The value the user enters for an attribute in any tuple in any relation must belong to domain of that attribute and it should be atomic, means it should be indivisible. Further, we should not be able to divide it. It should be okay. We saw to the domain of salary attribute as integer type of data and the range being 15,000 to 90,000. So the data type can be short integer, integer and long integer. For integer data type, float, double precision float for real numbers, or data type can be characters, boolean, fixed length strings and variable length strings, or data type can be date, time, timestamp or other special data types. So domain also can be described by sub-range, like how we had mentioned for salary from 15,000 to 90,000. Another example, if you consider for age attribute in any relation, there the range can be specified as 18 to 55. Then the value that user can fill for age attribute in any tuple in any relation must be within this range. Okay, that is all about domain constraints, in which a value a user can enter for any attribute in any tuple of any relation must be of the same data type specified for that attribute and must be within the range that is specified for that attribute. Okay. Next, the second type of constraints under schema-based constraints or explicit constraints is key constraints. By definition, all the elements of a set are distinct. So relation also is a set of tuples. So tuples in a relation must also be distinct. This means that no two tuples can have same combination of values for all their attributes. That is, if you take two tuples T1 and T2, the values of any attribute, if you take, they should not be same. That is what the meaning of key constraints. So in simple word, no two duplicate tuples can exist and tuples are said to be duplicate when all the attribute values are same for both the tuples. Any one has to be different. The meaning is, for example, consider employee relation. Here we have 10 attributes, that is F name, M init, L name SSN, BDate, address, gender, salary, super SSN and DNO. Consider tuple T1 and T2. For F name attribute in tuple T1, the value is John and Franklin in second tuple. So the attribute F name values are not same here. So if all attribute values are same in both the tuples, then we say that the tuples are same. They are the duplicate tuples. So for all the attributes, value should not be same in any relation. So no two duplicate tuples can exist in a relation. That is what is the meaning of key constraints. Okay. Next, third type of constraints under schema based constraints or explicit constraints, that is constraints on null values. It specifies whether null values are permitted or not permitted. For example, if every student tuple must have a valid non-null value for name attribute, then name of student is constrained to be not null. Constraint to be not null means null values are not permitted. Okay. Let us consider an example for constraints on null values. Here we have a relation student. It has three attributes: roll number, name and height. Roll number attribute is underlined because it is primary key. So to create such structure, that is table called student, structured query language command, that is SQL query, is used. That is as follows. So the SQL query is create table, the name of the relation student. The three attributes roll number, name, height are taken here. So roll number is made as primary key. That is first point. Next, name attribute is constrained to be not null. So name attribute is constrained to be not null. So that is specified here. Means null value is not permitted. So when we insert values into student table, so for example roll number 1 is entered here, but when it comes to name attribute value, since null value is not permitted, we have to enter the name compulsorily. Okay. That is what is the meaning of this. Constraint to be not null means null value is not permitted. We have to compulsorily enter the value of that attribute. Okay. Next, height attribute value is not constrained to be not null. So here height attribute is not constrained to be not null. So null value is permitted. So for this height attribute, the value if we don't know at present, because height of a student exists, at present we may not know the value, then we can enter null value because it is permitted. When we come to know the value, then we can replace with the actual value. That is what is the meaning of this. Not constrained to be not null, hence null value is permitted. Okay. So here not null constraint is enforced in DDL command, that is create table command. Next, whether an attribute value is constrained to be not null, that is null value is not permitted, not constrained to be not null, that is null value is permitted, that depends on the application. Okay. That is what is all about constraints on null values. Okay. Next, fourth constraint under schema based constraints or explicit constraints is entity integrity constraints. This entity integrity constraint states that no primary key value can be null, because primary key value is used to identify individual tuples in a relation. Having null values for the primary key implies that we cannot identify some tuples. So this employee relation, if you take for example, there are 10 attributes. This SSN, social security number, that SSN attribute is underlined. means it is primary key here. So its values are given for every tuple here. It cannot be null because every tuple is identified by this SSN value. If it is null, these tuples cannot be identified because in real life names can be same. Then we cannot identify these tuples, but primary key value will be different, and if they are there we can identify. If they are made null, we cannot identify the tuples. That is what is the meaning of this entity integrity constraints. Primary key value cannot be null for any tuple in any relation. Okay. Next, the fifth and the last constraint under schema-based or explicit constraints is referential integrity constraints. The referential integrity constraint states that tuple in one relation that refers to another relation must refer to an existing tuple in that relation. That is, for example, if you consider two relations, employee and department. Here employee is John B. Smith. He is the social security number, that is SSN is 123456789. But suppose if his department name is required, then in this tuple we collect DNO, department number, that is 5. Then we go to department table where D number is 5. In that tuple we collect D name attribute value, that is research department, and that is the department name value of John B. Smith. Okay. That is how from one relation to another relation, if we refer for any attribute value, then that should be existing there. So for department number 5, we referred in department table here D number value, which is 5, it is existing. Suppose if you take 7 here, it is not existing here, then we cannot refer. That is what is the meaning of this referential integrity constraints. The referential integrity constraint states that a tuple in one relation that refers to another relation must refer to an existing tuple in that relation. So which is not existing, we cannot refer. Okay. This gives rise to the concept of foreign key. Okay. That completes the discussion on all the 5 constraints which come under schema-based constraints or explicit constraints. That is domain constraints, key constraints, constraints on null, entity integrity constraints, and referential integrity constraints. Okay. Next we shall move on to third type of state constraints, that is application based or semantic constraints or business rules. Next, third type of constraints under state constraints is application based constraints or semantic constraints or business rules. Semantic integrity constraints, they are not part of DDL, means data definition language commands, and they have to be specified and enforced in a different way. The example for such constraints are the salary of an employee should not exceed the salary of another employee, means you can take a supervisor here. So supervisor salary must be greater than any other employee. So the salary of an employee should not exceed the salary of supervisor. Another example is the maximum number of hours an employee can work on all the projects per week is 56. Such constraints can be specified and enforced within application programs. So mechanisms called triggers and assertions can also be used in SQL through the create assertion and create trigger statements to specify some of these constraints. So whatever constraints we discussed so far, They belong to state constraints. So another type of constraints, they are called as transition constraints. They can be defined to deal with state changes in the database. Example, the salary of an employee can only increase. Such constraints are typically enforced by the application programs or specified using active rules and triggers. And that is all about relational model constraints and relational database schema. Okay. So whatever constraints we studied so far, how they are violated when user does some operations on the database. So the user operations can be update operations, transactions, and any violations then if occur, how to deal with them. There are three basic operations that user will be doing, due to which there will be change in the state of relations in the database. So those three kind of operations are insert, delete and update. So update operation means here modify. So when user does insert operation or delete operations or modify operations, they are called as update operations. So here insert command or operation is used to insert one or more new tuples in a relation. Delete is used to delete one or more tuples. Update operations means modify. Operation is used to change the values of some attributes in existing tuples. So next we shall see some examples for this while doing these update operations, that is insert, delete or modify operations, how user might violate the constraints and how they have to be dealt. Okay. So for that let us see first operation, that is insert operation. This insert operation is done to employee relation. So this is the employee relation. There we have 10 attributes, that is F name, M minute, L name, SSN, B date, address, gender, salary, super SSN and DNO. Here values are specified for insertion and they have to be in the same order as that of attributes. So the first one belongs to Cecilia, the second one belongs to M minute, the third one belongs to L name, the fourth one, that is null value, that belongs to SSN. Now whether this insert operation is going to be successful, yes or no, depends on the values given here, because null value is mentioned for SSN, which is primary key. According to entity integrity constraint, null value is not allowed for primary key. So this insert operation is rejected because it violates entity integrity constraints, means it enters null value for primary key SSN, which is not allowed. Okay, so that is what is about one insert operation. Next we shall see some more examples for insert operations. Okay. Second example for insert operation. Here Alicia value is mentioned for F name attribute, J for M minute, Zelaya for L name and this value for SSN. Next birth date value, next address value, then gender value, then salary value, then who is the supervisor, that person SSN value, and lastly department number value is mentioned to be inserted into employee relation. Okay. The question is this insert operation is going to be successful, yes or no? This insert operation is rejected because it violates key constraint. Here we have another tuple with the same SSN value. So what SSN value is mentioned here? It is already existing here. So there cannot be duplicated values for primary key. That is what is key constraint states. Hence this insert operation is rejected. So far we saw two insert operations. The first insert operation was rejected because their primary key was specified to be null. In the second one, primary key value was repeated or duplicated. So primary key cannot be null or primary key value cannot be duplicated. Now we shall see to third insert operation. So here Cecilia value is mentioned for F name, F for M minute, colon key for last name, this value for SSN, and this is for birth date, this is for address, and this F for gender, 28,000 for salary, this is for supervisor number, and 7 for department number. These values are to be inserted into employee relation and this one. Whether this insert operation is going to be successful. So think for a while. So this insert operation also is it is rejected because it violates referential integrity constraint. What is the meaning of this? Here D number mentioned, that is 7. So for insertion this D number, department number mentioned is 7. When it is mentioned here, but that must be present in the department relation. So here if you see to department relation, 5 is present, 4 is present, 1 is present, 7 is not present. Hence in employee relation, if you insert a tuple with D number equal to 7 which is not present here, that violates referential integrity constraint, and hence such kind of insert operation cannot be successful. So to insert any DNO value here, that must be present first here, then only it can be successful. And that is what is violation of referential integrity constraint, in which in this insert operation department number 7 is being inserted in employee relation because that department number 7 doesn't exist in department relation, that cannot be inserted into employee relation. Hence this insert operation is rejected. Okay. Next we'll see to fourth insert operation. Cecilia is mentioned for F name. F value is for M minute, colon key for last name. This is for SSN. This is birth date. And next address. This F for gender. 28,000 for salary. Null value for super SSN. 4 for DNO. Is this insert operation is going to be successful? Pause the video and think for a while. So if you observe SSN value here and this nowhere present here, and SSN value is not mentioned null also. So it is not violating entity integrity constraint where primary key value cannot be null. It is not violating key constraint that primary key value cannot be duplicated. Then third one, department number 4 is mentioned. So in department relation 5, 4, 1 were present. So 4 is present. So it doesn't violate referential integrity constraint also. Hence this insert operation must be successful. So let us see. So this insert operation satisfies all constraints. It is acceptable. Okay. And those were the 4 examples for insert operations. So the first operation showed primary key value cannot be null. That is, insert operation cannot violate entity integrity constraint. The second one, primary key value cannot be duplicated. That is, insert operation cannot violate key constraint. And the third one, insert operation cannot violate referential integrity constraint. That is, if you want to insert any tuple in the first relation, that should be present in the second relation for reference. That is, we try to insert a tuple in employee relation with department number equal to 7, and that department number was not present in the reference table, that is department relation. So it violated referential integrity constraint. So that is why it was not successful. And fourth one was not violating any of these constraints, and hence it was successful. Okay. Next we shall move on to delete update operation. Now let us discuss delete operation. Before discussing delete operation, let us recall some conclusions from insert operations. So considering this typical insert operation which was not acceptable because of violation of referential integrity constraint. So what that constraint means, this employee relation and department relation both are linked. So employee relation is referencing relation and department relation is referenced relation. So what is the meaning of that? In employee relation, employee details are given. But for any employee, if you want the department name, for example, John B. Smith employee, if you consider, what is his department name? So in this employee relation, in this tuple, his department number is given, but name is not given. Then to find its name, we'll have to refer to department relation. Taking this DNO equal to 5, we'll have to go to department relation where D number is equal to 5. In that tuple, this D name attribute value, that is research, will be the department name of John B. Smith. Okay. So this employee relation is referencing, department relation is referenced relation. So as per this insert operation, the tuple we cannot insert here with DNO equal to 7 because that is not present in the referenced relation. Hence here we cannot insert. That is first one. If you extend it to delete operation, this tuple if you take where research department D number is 5, then MGR SSN is given, MGR start is given. This tuple we cannot delete because it is referenced by tuples in other relation. Okay, so this is reference relation. We are not free to delete because it is referenced by the referencing relation, that is employee here. Okay, next we shall continue with this delete operation. So delete the works on tuple with ESSN equal to 999887777 and PNO equal to 10. So the works on tuple means the tuple belonging to works on relation. So ESSN value, so that ESSN value is found in these two tuples. But out of 2, where PNO equal to 10, PNO equal to 30 here, PNO equal to 10 here, and hence this is the tuple that is to be deleted as per this delete operation. Now can it be done? Is it acceptable? That is the question. Now referential integrity point of view, if we think, so this is works on relation, this is employee relation. So works on relation is having the ESSN value, that is employee SSN value, and project number, means that employee works on which project, that project number, and for how many hours he or she works on that project. Those details are stored. So this ESSN, which employee, what are his or her details, means then we'll have to refer to employee relation. Means this will be referencing relation, this will be referenced relation. We are not trying to delete in referenced relation, we are deleting in referencing relation in this operation, and hence we are free to delete. So the result is the deletion is acceptable and deletes exactly one tuple, that is this tuple. Okay. So now we can extend our conclusion. So while insert operation, we cannot insert in referencing relation that which doesn't exist in reference relation. That is first point. We cannot delete any tuple in reference relation if it is being referenced by tuples of other relation. Okay, these 2 points are very important. As far as referential integrity constraints are concerned in case of insert and delete operations. Okay, you'll have to remember this. Next, see to second delete operation. Delete the employee tuple with SSN equal to 999 So this delete operation is to be done in employee relation. The tuple where SSN equal to, so SSN equal to 999 means this tuple has to be deleted. Can it be done? Is it acceptable? That is the question. Then referential integrity point of view, if we think this relation is referenced relation, works on relation is referencing relation. So this SSN is present here in works on relation. So for employee details, this works on relation refers this employee relation. Hence we are not free to delete this tuple in this operation because that is referenced by these two tuples in referencing relation. Okay. This is according to one of the conclusion that we did in the previous example. So if we do conclude properly and remember those conclusions, then it helps for further operations. Okay. Here the result is this deletion is not acceptable because there are tuples in works on that refer to this tuple, means this tuple. Hence, if the tuple in employee is deleted, means if this tuple is deleted, it violates referential integrity constraint. Okay. Hence, in this delete operation, this tuple cannot be deleted. Next, we shall see to the third and the last delete operation. Delete the employee tuple with SSN equal to 333445555. This delete operation is on employee relation. There the tuple is with SSN equal to this, means that is present here. Hence the tuple to be deleted from employee relation is this tuple. So is this delete operation acceptable? That is the question. For that, if we think referential integrity constraint point of view, in this database are there any relations linked to this relation, that is employee relation? Is this mentioned tuple being referenced by any other tuples of other relations? So that is the question. So if you consider department relation, so this SSN is present in this department relation tuple here. Means it is of manager. So this manager details means then department relation, this tuple refers to the mentioned tuple in employee relation. So now department relation is referencing relation, employee relation is referenced relation. So for that reason we are not free to delete this tuple from referenced relation. That is first point. In second point, if you consider this dependent relation, this SSN is present in three tuples. Here three people are the dependents. They are the dependents of this employee. So which employee means those three tuples will refer to this tuple from employee only. So now in that case, dependent relation is referencing relation, employee relation is referenced relation. For that reason, then also we are not free to delete this tuple from referenced relation. So in third case, if you consider works on relation, this SSN is present in four tuples. So this works on relation gives this SSN, then PNO, that is project number, means that employee is working on which projects. So that project numbers it gives, then for how many hours on each project. Those details are given in this works on relation. So this employee, what are that employee details means all these four tuple refer to this tuple from employee relation. In that case, works on relation is referencing relation and employee relation is reference relation. So in that case also, we are not free to delete this tuple from referenced relation. So let us see to the result. So the result is, this deletion will result in even worse referential integrity violation because the tuple involved means this tuple is referenced by tuples from department relation, okay, works on relation, then dependent relation. But here it is being referenced by employee relation also, it is given. What is the meaning of that? Let us see next. So this SSN is present here in employee relation under super SSN attribute. Means super SSN means supervisor social security number. So that is that supervisor details means this tuple will reference back this tuple from employee relation only. Then in that case, employee relation is the referencing relation and employee relation itself is the referenced relation. So supervision is the recursive relationship in which employee entity references back the same employee entity type only. Okay, so in that case also we are not free to delete this tuple because it is in the referenced relation. Hence, as per result, this deletion will result in even worse referential integrity violation because the tuple involved means this tuple is referenced by tuples from employee means this one, department means this tuple, works on means these four tuples, and dependent relations means these three tuples. So from referential integrity constraint violation point of view, this delete operation is not acceptable. Okay, that completes the discussion on delete operation. Next we'll have to see modify operation under the set of update operations. Next we shall discuss on update operation. In that first update operation, that is update the salary of the employee tuple with SSN equal to 999887777 to 28,000. That means that SSN is present here. So in this tuple, the salary value has to be changed to 28,000. That is what is mentioned in this update operation. The next question is it acceptable? So the result is it is acceptable. The reason is here DNO attribute links department relation and employee relation, and super SSN attribute links employee relation with employee relation only. So but salary attribute is not linking any relation, hence we are free to update this. So this result shows that this update operation is acceptable, and in this tuple of employee relation, salary value that is modified from 25,000 to 28,000. Okay. Next we shall see to second update operation, that is update the DNO of employee tuple with SSN equal to 999887777 to 1. That means in employee relation where SSN equal to, so that is 999887777 is present here. That is in this tuple the DNO value must be modified to 1. The question is it acceptable? So the result is it is acceptable. Okay, because here DNO, which was 4, now it is being modified to 1. This 1 is present in linked relation, that is department relation. Already we have seen that there is link between employee relation and department relation. Employee relation is the referencing relation and department relation is the referenced relation. So in the referencing relation, this value 1, DNO equal to 1 is valid because that is present in referenced relation. Hence, this update operation is acceptable. Okay. So here if you observe in employee relation where SSN equal to 999887777, in that tuple if you make DNO equal to, that is 1, if you modify, that is valid because this 1 is present in referenced relation. Okay. Hence we can say that this update operation is acceptable and DNO equal to 4 can be modified with 1. Okay. Next, taking third update operation, that is update DNO of employee tuple with SSN 999887777 to 7. This already we have discussed. This is not acceptable because it violates referential integrity constraint. Here the SSN value, this is present here in this tuple. This DNO has to be changed from 4 to 7. So that is not acceptable because this value is not present. It's a linked table, that is a department. So already we have seen that employee is the referencing relation, department is the referenced relation. So for DNO attribute value, whatever it is present here, that must be present in the referenced relation under D number. So this 7 is not present, hence this update operation cannot be done. So here we have employee relation and department relation. DNO attribute is present and the tuple with SSN 999887777, in that tuple if 4 is to be modified from 7, then it is not valid, it is not acceptable because this DNO equal to 7 is not present in department relation under attribute D number. Here only 5, 4, 1 are present, 7 is not present. So which is not present in reference relation, that is not allowed in referencing relation. So in that case, this update operation is not acceptable because it violates referential integrity constraints. Hence this 4 cannot be modified with 7. Okay. Next let us see to update operation 4, that is the last one. Update the SSN of employee tuple with SSN equal to 999887777 to 987654321. The meaning of this operation is, so in employee tuple we have to do updation. So where SSN equal to this 999887777, so that has to be updated with this new value. Okay. The question is it acceptable? So pause the video and think for a while. The result is this. It violates referential integrity constraints because there are other relations that refer to the existing value of SSN. So existing value of SSN means this 999887777. So because it is being referenced by other relation tuples, here we are not able to modify it in the update operation. That is what is the meaning of this result. So let us see which all other relation tuples are referencing this. Okay. So if you see in department relation, nowhere we have this SSN. Okay. That is why department relation any of the tuples are not referencing. Then in dependent relation, nowhere that SSN is present, and hence this dependent relation is also not referencing that SSN. So in works on relation, so 999887777 that is present in two tuples. Means in this relation, so these two tuples, so their project number 30 and 10 is given, hours value that is 30 and 10 is given. They are the values for these attributes. Means this employee is working on project number 30 and 10 for 30 hours and 10 hours. That is what is the meaning here. Okay. So now what are the employee details with this SSN means, then it will refer to the tuple here in which that SSN is present. So this value of SSN is needed. We cannot change with the new one because that is being referenced by works on two tuples. That is what is the meaning of this. Okay. With that we come to the end of update operations, and that completes the whole discussion on chapter 5, that is the relational data model and relational database constraints. I hope you understood. Thank you.